So before starting with the topic design of steel structure and its connection using Staad Pro, Idea Statica and Excel, let's understand what is steel. Why is steel used as a structural member? What is the advantage of steel? What are some of the properties of steel? Let's have a small overview why it is important. The number one advantage and the number one property of steel, of course, is the strength. It has some particular structural strength. That is the reason steel is used as a structural member. Second, it is a ductile member. What does ductility mean? That means it can bend and again it can regain its original shape. It is ductile member. Third, it is durable. So when you apply force over it, it won't easily break. It is a durable member. Fourth, it is recyclable. Steel is a recyclable material. So once you have constructed, once you have used it, and if you want to demolish it, if you don't want the structure, you can just melt it and reuse it for any other use. So it is a recyclable material. So it is sustainable material. Next is fire resistant. Steel generally as a structure, as a material is not fire resistant, but when you apply any particular coat over it, there are many fire resistant coat available in the market. When steel is applied with fire resistant to a very large extent. So generally in construction, when we use steel as a structural member, we apply some coat over it. In that case, steel becomes a fire resistant member. And next, last advantage, the most important advantage, it is a uniform material. So throughout the length of the member, throughout the cross section, at any area, you will find similar properties of steel. So it is uniform across the length and across the width, across overall volume of the member. This is not the case in case of concrete, because concrete we mix it with mortar, we mix it with stones, we mix it with aggregate. So it is not very uniform and the strength might vary from section to section. There is a slight variation. But in case of steel, as it is a uniform member, we can have similar kind of properties at any cross section, at any location, along any length. So these are some of the properties of steel. This is the reason why we use steel as a structural member. Now let's discuss some of the brief mechanical properties. First, modulus of elasticity. Modulus of elasticity is also called as the Young's modulus, is the strength of your material, that is 200 GPa, or if you want to have into megapascal, it is 2 into 10 to the power 5 megapascal. If it is sometimes taken as 2.05 or 2.1, generally it ranges between 2 or 2.1. So 200 GPa or 2 into 10 to the power 5 MPa, modulus of elasticity of steel. So this is the value what we will be using in our design. This is the mechanical property of steel. Modulus of rigidity. Modulus of rigidity of steel is around 77 GPa or 0.7 into 10 to the power 5 MPa. Next, we have coefficient of thermal expansion. If you are using your material, if you are using steel in thermal, in a temperature friendly environment where you also want to check the effect of temperature, then you need this coefficient of thermal expansion, which is 12 into 10 to the power minus 6 per degree. And the last one, Poisson's ratio. This is between 0.5 to 0.3. So these are some of the basic mechanical properties, some of the basic material properties of steel. But what is important for us is the modulus of elasticity, which is also called the Young's modulus, which is around 2 into 10 to the power 5 megapascal. So this is the stress strain curve which all of us have seen during our graduation. This is the graph which is plotted strain in the x-axis and stress in the y-axis. So you can see initially we have a straight line. That means the material is linear up to certain point, which is the yield strength of the material. Up to this point, we have a straight line. That means whatever force we apply on our member and it bends, but when the force is removed, it again comes to its original shape. That is the reason we have a uniform line. This limit is called the elastic limit. Up to yield strength of the material, the maximum value of strength at which the material will gain its bent again, that is called the yield strength of the material. And up to that limit, our material is under elastic limit. After that, the ultimate strength means the stress at which the material will fail, steel will bend or break. That is called ultimate strength, the maximum strength which our material can take, which steel can take, that is the ultimate strength. During this region between the yield strength and ultimate strength, that is the plastic region. So we decide whether we want to design our material, we want to design our section in the elastic region or in the plastic region. So this is the stress strain curve. Okay, so as in case of concrete, we have various grades of concrete like M5, M10, N15, M20. Nowadays we have M30, 40, M50, M60. But in case of steel, we have grades of steel as per IS 2062 2011. So these are some of the grades of steel. Generally, the hot rolled sections like maybe ISMB 600, ISMB 500, ISMB 200, or the channel sections ISMC 100, ISMC 150, or the angle sections ISA. These all standard Indian sections. Generally, they are of mild steel. That is the reason the grade of those member is E250. But you might have seen the reinforced bars which we use in our RCC structures. Those have the grade like FE 410, FE 500, FE 550. So these are some of the grades that is based on IS 2062.